Hello students, welcome to MEMONEET. I am Aprajita, your chemistry tutor. So today we are going to discuss the solutions for the full length test 8. So let's start with our question number 51, which says the correct IUPAC name of the following compound is. So here ET is ethyl, that is CH2, CH3. So we can write the compound like this here. Now we know according to the lowest set of locant rule, the numbering is done in such a way so that the substituents get the lower number. So if we number it from right hand side, the substituents will not get the lower number, they will come at third and fourth carbon. But if we number it from the left hand side, they are coming at the first and the second carbon. So that's the correct way of numbering. Now the name will be written. Now there are different substituents attached to it. So the substituents will be written in alphabetical order. So yeah, firstly we will be writing 2 bromo, then 1 fluoro, 1 ido, and then 2 nitro. And since there are 4 carbon atoms, so it's a butane with because there are no double or triple bonds. So that is going to be the IUPAC name of the compound. So the answer is option 3. 2 bromo, 1 fluoro, 1 ido, 2 nitro, butane. Okay, now the next one is the species in which the bond is non-directional is. So we have NCl3, rubidium chloride, BeCl2 and BCl3. Now students, we all know that the ionic compounds, they are non-directional. Non-directional means they have no geometry. Whereas the covalent compounds are having geometry, so they are directional. Now in the options here we can see that NCl3 is a covalent compound. Rubidium chloride. Now rubidium is electropositive and chlorine is an electronegative element, and the electronegativity difference is more than 1.7, so it's an ionic compound. Then if we look at beryllium chloride and boron trichloride, both of them are covalent compounds. So it means the correct option would be option number 2, rubidium chloride. Since it's an ionic compound, it is non-directional because ionic bonds are non-directional. So let us have a look at question number 53. So it says that the Avogadro's number, if it is changed from 6.022 into 10 to the power 23 to 6.022 into 10 to the power 20, the number of atoms present in 11.2 liters, you can write 2, of a diatomic gas. So here it's a diatomic gas at STP would be. So Avogadro's number is 6.022 into 10 to the power 23. Now it has been changed, so let it be Na dash. So we know that the mass of Avogadro's number of atoms is known as Avogadro's number of atoms or molecules is known as molar mass. So now according to the changed Avogadro's number, mass of 6.022 into 10 to the power 20 molecules of gas will be molar mass. Now we will find number of moles of the diatomic gas. So number of moles is given mass upon molar mass. So given mass is 11.2. Okay, so it's a gas here. So we will say that it would be given volume upon the molar volume. And we know that 1 mole of any gas at STP occupies 22.4 liters of the volume. So molar volume will be 22.4 and given volume is 11.2. So the number of moles come out to be 0.5. So the number of atoms, since it's a diatomic gas, so the number of atoms would be the number of moles multiplied by Avogadro's number multiplied by 2. So it is coming out to be Na dash only, which is 6.022 into 10 to the power 20. So the answer is option 4. Now let's have a look at question number 54. Resonance stabilizes the molecule as the energy of the resonance hybrid is. Now we know that low energy state corresponds to stability, and The resonance stabilization means lower energy state. So the resonance hybrid, it is actually in a low energy state as compared to its canonical structures. So the answer would be that the energy of resonance hybrid is less than the energy of single canonical structure. So it is option 2 for question number 54. Now let's have a look at question number 55. So we have to find out the incorrect statement here. So it's about the stability of the carbocations. So in this case, allyl carbocation is less stable than propyl carbocation. So allyl carbocation, here you can see, it is actually stabilized because of resonance. So you can see the resonance structures here. It is stabilized because of resonance. So it will be more stable than the propyl carbocation. So definitely it's not a correct statement. Okay. So because of resonance, it is more stabilized. Now ethyl carbocation is less stable than allyl carbocation. Same reason, allyl carbocation is more stable because of resonance. Now vinyl carbocation, this one, is less stable than ethyl carbocation, because ethyl carbocation has inductive effect and hyperconjugation, but here inductive effect is less because here double bond is present. So this is also correct. Now benzyl carbocation, CH2 positive, is less stable than cyclopropyl methyl carbocation, because in cyclopropyl methyl carbocation there is overlapping of the ring with the vacant p orbital. So because of overlapping, it is more stable. So yes, the answer would be option number 1. This one is incorrect. Allyl carbocation is less stable than propyl carbocation is incorrect because it's more stable. Now in question number 56, we have to find how many tertiary carbon atoms are present in the product Y. So we can see here that HBr is added and then sodium in the presence of triether. So here from the cyclohexane ring structure, first of all HBr will be added across the double bond, okay, and after that two new CH bonds will be formed. So they are attached to the tertiary carbon. Since two new CH bonds are formed, so we can say there will be two tertiary carbon atoms. So the answer is option number 3rd. Now which of the following molecule has trigonal bipyramidal geometry with bond angles 120 degree and 90 degree, that we have to tell. So if I talk about SF6, so it has an octahedral geometry like this. So we can see here it will be having an octahedral geometry. SF6. Now if I talk about PCl5, so you can see here that it is having trigonal bipyramidal geometry. It shows sp3d hybridization. So trigonal bipyramidal geometry is there. Methane CH4 has a tetrahedral geometry, whereas BF3 is trigonal planar. So it means trigonal bipyramidal is PCl5, option number 2. Now let's move on to question number 58. So here we have to determine the molality of 1 liter of solution of 80% weight by volume H2SO4. So H2SO4 is the solute here and the density is given 1.8 gram per milliliter. This is the density of solution. So we know that molality is number of moles of solute present per kg of the solvent, means mass of solvent in kg. So we have to find the mass of solvent here. Now 80% weight by volume means 80 grams of sulfuric acid is present in 100 ml. So if it is in 100 ml, so we can say that in 1 liter means 800 grams of sulfuric acid will be present in 1000 ml of the solution. Okay, so now we need to find the mass here. So volume is given multiplied by density, which is 1.8. So 1000 into 1.8 will give 1800. It means we can say 800 grams of sulfuric acid is present in 1800 grams of solution. So mass of solution is there, mass of solute is there. We need to find the mass of solvent. So it will be coming out to be 1000 grams. Now we can find the molality. Now number of moles of solute will be given mass, which is 800, and we know that the molar mass of sulfuric acid is 98. So 800 upon 98 and the mass of solvent in kilograms. Now the mass of solvent is 1000 grams means 1 kilogram. So upon 1. So 800 upon 98 will be 8.16 molar. So we can say the answer is option 3. Now question number 59. Which of the following statement is incorrect regarding Fajan's rule? So yes, Fajan's rule discuss the partial covalent character of ionic bond. This is true. So next, we all know that smaller the size of cation and larger the size of anion, greater will be the covalent character because there will be more polarization then. And similarly, greater the charge on the cation, greater will be the covalent character of the ionic bond. Now we know that for the cations of same size and charge, those with electronic configuration of transition metals are more polarizing than noble gas. So here it's given that noble gas will be more polarizing. So this is a wrong statement. So the answer is option 4 because we had to find the incorrect statement. So that is the answer. Now, which of the following reactions cannot be used to form benzene? So here we know that acetylene CH triple bond CH, it undergoes cyclic polymerization in the presence of red hot iron tube. Now here we have N-heptane. So N-heptane in the presence of chromic oxide, it will give us toluene. If it would have been N-hexane, then it would have given us benzene. So this is definitely not giving us benzene. Now sodium benzoate, in the presence of, here the reactants would be changed, in the presence of NaOH and CaO, calcium oxide. So here decarboxylation will happen and we will get benzene. And phenol, in the presence of zinc dust, when heated, it also gives benzene. So from option 2, we are not getting benzene. So that's the answer. Now question number 61. Energy of second Bohr's orbit of hydrogen atom is minus 328 kilojoule per mole. So we can say E2 is given. We need to find the energy of the fourth orbit. So we know that the energy is inversely proportional to n square, that is the orbit number. So for hydrogen atom, we all know that the atomic number is 1. So we can take the ratio of E2 and E4, that will be N4 square upon N2 square. So that is N4 will be, so here we will be writing 4 upon 1 because 16, 4 upon N2 square will be 4. So that will be 4 upon 1. So E4 will be E2 divided by 4. So we'll divide it by 4 and we'll get minus 82 kilojoule per mole. So we have to make it inversely proportional to the orbit number. Now next question 62. C60 an allotrope of carbon. So we know that C60 is an allotrope of carbon, which is fullerene, or it is known as Buckminster fullerene. It has a soccer-like shape, like a shape of a soccer ball, which contains 20 pentagons like the 5-sided figure like this, and 12 pentagons and 20 hexagons. So 12 pentagons, 20 hexagons, the answer is option 2. Now let us move on to question number 63. So the measurement of electron position is associated with uncertainty in momentum, which is equal to 1 into 10 to the power minus 18 gram centimeter per second. So uncertainty in momentum is given. We have to find out the uncertainty in velocity. Mass of electron in grams is given. So we know that according to Heisenberg uncertainty principle, so delta P is m delta V. So we have to find the uncertainty in velocity. So delta V will be delta P upon mass. Delta P is given, mass is given. When we divide it, it comes out to be 0.92 into 10 to the power 10. So we can say it's around 10 to the power 9. 0.1, so we can consider it. So 0.9 into 10 to the power 10 means 10 to the power 9 centimeter per second. So it's option number 2. Question 64, which of the following statement is incorrect? All members of group 14 are solids. This is true. Yes, all members of group 14 are solids. Next is carbon and silicon are non-metals, whereas germanium, tin and lead are metals. So if we look, carbon and silicon are non-metals, but germanium, it is a metalloid. It's not a metal, it's a metalloid, whereas tin and lead are soft metals. So this is not a correct statement. Melting point of group 14 are higher than the corresponding elements of group 13 because of strong binding forces. This is also true. So it means the incorrect statement is the second one. The answer is option 2. Now, according to Bohr's theory, which of the following transition in hydrogen atom will give rise to least energetic photon? That we have to tell. So we know that if the difference between energy is least, then it will give rise to least energetic photon. So we know that since delta E is the energy is inversely proportional to n square. So for the transition, here we can say delta E will be 1 upon n1 square minus 1 upon n2 square for the transition n2 to n1. So here we can see the difference in energy would be least in 6 to 5. So it means when electron will move from 6 to 5, it will give the least energetic photon. So answer is option 3rd. Now question number 66. So here we can see all hydrides of group 16 elements except one possesses a reducing property. This character increases from H2S to H2Te. Now which hydride does not possess reducing property? That is water. Because of the strong oxygen hydrogen bond, more electronegative nature of oxygen. Since oxygen is more electronegative, so here the reducing property is not there because the oxidation number cannot increase. Moreover, this bond is strong and water exists as an associated molecule and others don't. And the reducing character increases from hydrogen sulfide to H2Te because of the decrease in stability of the hydrides. So yes, the answer is option number 2. Next is question number 67, which says that which of the following elements can be involved in p pi d-pi bonding, that is carbon, nitrogen, phosphorus and boron. So out of the given options, only phosphorus is the one that is having vacant d orbitals. So if it is having vacant d orbitals, it is the one that can be involved in p-pi d-pi bonding. Carbon, nitrogen, boron, they are not having the d orbitals. So yes, the answer is option number 3. Now question number 8, which of the following compounds are gases at room temperature? So we know that the ones that are having low molecular weight, they'll be having weak forces of attraction. So if they have weak forces of attraction, so they'll be existing as gases. So usually the lower members of any homologous series, they exist as gases. So here we can see that methyl chloride and methyl bromide are the ones which are small molecules. They will be having weak forces of attraction as compared to long chain alkyl halides. So the answer is option 4, that is only 3 and 4 will be gases. Now the question number 69, filling of 4f with 4,5d orbitals result in a decrease in atomic radii. So this phenomena is called lengthenide contraction. So lengthenide contraction, it is actually the decrease that we see in atomic size because of poor shielding by 4f electrons. So because of the poor shielding by 4f electrons, it actually compensates for the expected increase in atomic size and it results in decrease in atomic radii. So the process is called lengthenide contraction. It's option number 1. Question number 70. A solution of urea has been prepared by dissolving 30 grams of urea in 500 grams of water. So urea is the solute here and its mass is 30 grams and water is the solvent. Freezing point of the solution will be, so we have to find the freezing point, means we know that there will be lowering of freezing point, so that we have to find out. So here we can see the formula of delta TF is I into M into KF. Now we know that KF is the freezing point lowering constant, M will be the molality and I is the Van 't Hoff factor, which depends on how many ions are produced in this case. Since here urea is a non-electrolyte, it does not produces any ions, so here the value of I would be 1. Now molality, you all know, it's the number of moles of solute present per kg of the solvent, mass of solvent in kilograms. So here we can write the formula of molality. So number of moles will be 30 upon 60. So here, and the mass of solvent is 500. So here we can 500 grams into 1000. So we can do it. Alright, so here we can say that Kf is given 1.86. So once we find out the molality, multiply it with I and Kf, so the value will come out to be 1.86. So now we have to find out the freezing point. So it will be, you know, the freezing point of water is 0 degrees Celsius. Then the lowering of freezing point, we'll be subtracting it. So it means it will be minus 1.86 degree Celsius. So the answer is option first. Now next up, magnetic moment of a transition metal ion is 3.87 Bohr magneton. The number of unpaired electrons. So we know that the magnetic moment mu, it is denoted by n into n plus 2 square root, where n is the number of unpaired electrons. So once we put the value here 3.87 square root of n into n plus 2, we will be solving it, and on solving it, it will be coming out to be 3. So means there are 3 unpaired electrons. The answer is option 2. Question number 72. Which of the following will form primary alcohol on reaction with Grignard reagent followed by hydrolysis. So we know that formaldehyde, which is HCHO, it gives primary alcohol on reaction with Grignard reagent. So if we have other aldehydes, they will be giving secondary alcohol, whereas the ketones will give tertiary alcohol. So here primary alcohol will be produced by HCHO, which is formaldehyde. Acetaldehyde will give secondary alcohol, as you can see here, and this acetone will give you tertiary alcohol. So the answer is option number 1, which is formaldehyde. Next is question number 73, a complex compound in which oxidation number of metal is 0. So we need to find the oxidation number of the metal here. So if we look at K4FeCN6, we can do it. So for potassium it's +1. So +1 into 4. Plus for iron we can take it as X. Now Cn has a charge of -1. So -1 into 6. So 4 plus X minus 6 equals 0, because it's a neutral compound. So the value of X will come out to be +2. So here it's +2. Okay, so similarly we can do it for K3FeCN6. It will be +3 here. Now here CO, carbonyl, it's a neutral ligand. CO, it's a neutral ligand. So the charge would be 0. So in FeCO5, the oxidation state of metal would be 0. And in this one also it's +3. So the answer is option number 3rd. Question number 74. If the enthalpy of combustion of butane is -2658 kilojoule per mole, means when 1 mole of butane burns, this much energy is there, enthalpy of combustion. How much heat energy would be released by combustion of 5.8 grams of butane? So 5.8 grams of butane, for that, uske liye we can find out the number of moles. So the number of moles will be given mass. Molar mass of butane would be 58. Like we can see, butane is C4H10. So 12 into 4, 48, plus 1 into 10. So it's 58. So once we find number of moles, it's 0.1. So for 1 mole, it's -2658. So for 0.1 mole, we'll multiply it with 0.1. So it will come out to be 265.8 kilojoule. So answer is option 2. Okay. So next up is question number 75. The geometries of the complexes formed by ammonia with nickel, platinum and zinc ions are. So with nickel, we know it will be octahedral, because it will be NiNH3 6. There will be 6 ligands attached to it. With platinum, it would be square planar, and with zinc 2 plus ions, it would be a tetrahedral geometry. So yes, the answer is option number A. Now question number 76, it is, arrange the following compounds in order of their susceptibility towards nucleophilic addition reaction. So let's see how we can proceed with this question. So we know that if there is an electro-withdrawing group attached with the carbonyl carbon, so in that case there will be more partial positive charge on the carbonyl carbon, making it more susceptible for a nucleophilic attack. Now let's have a look at these molecules. So acetaldehyde is CH3CHO, propanone is CH3 C double bond O CH3, phosgene is COCl2, and the last one is benzaldehyde. So it's C6H5CHO. Now the first thing is here chlorine. Two chlorine groups are attached in phosgene. So phosgene will be the most susceptible towards the nucleophilic attack, because chlorine are electro-withdrawing. So the first would be phosgene. Then after that it would be acetaldehyde, because there is only one CH3 group attached. On one side there is hydrogen. Now if we compare acetaldehyde and benzaldehyde, so in the case of benzaldehyde there will be delocalization of electrons with a benzene ring. Moreover, there will be steric hindrance because of a large benzene ring. Steric hindrance would be there. So that is why benzaldehyde will be less susceptible for nucleophilic attack than acetaldehyde. So second position will be acetaldehyde, then benzaldehyde, and here propanone, because in propanone there are two electron donating groups attached, which is CH3 and CH3. So it will be at the last position. So it will be 3, 1, 4 and 2. So answer is option first. Question number 77. If Kc for the reaction N2 plus O2 gives 2NO, so the equilibrium constant is given X, we need to find for this reaction. So we can look at this reaction. NO is on the reactant side. First we will be reversing the reaction. So once we reverse the reaction, 2NO will give you N2 plus O2. So for here Kc will be 1 by X, since we have reversed the reaction. It will be becoming reciprocal. Now to have this reaction, we'll divide it by 2. So NO will give N2 upon 2 plus O2 upon 2. So Kc is 1 upon, now we have divided it by 2. So it will be 1 upon square root of X, means 1 upon X raised to the power 1 by 2. So that would be the answer in this case, option number 4th. Question number 78. Which of the given metal ions will have T2G6 Eg0 configuration? So T2G6 configuration means there are 6 electrons in the valence shell. So there are iron. If we look at iron, if iron is in +2 oxidation state, it will be having 6 electrons. +3 oxidation state, it will be having 5 electrons. So option 2 cancels here, because here iron is in +3 oxidation state. In first and now here also it's in +3 oxidation state, so we are left with FeCN6 4 minus, so it's in +2 oxidation state. Moreover, here we can see all the electrons are paired because it's T2G6. So it means the ligand must be a strong field ligand. So Cn is a strong field ligand, so we can say the answer is option number 3. Now the next one is, which of the given carbonyl compounds will give a colored crystalline compound on reaction with this? So it is 2,4-dinitrophenol, dinitro, so 2,4-dinitrohydrazine. Phenylhydrazine, 2,4-dinitrophenylhydrazine. So we know about the 2,4-DNP test. So as we can see here, the 2,4-DNP test is given by aldehydes and ketones only. Acid chloride will not give it, so first option cancels out. Ketone will give it, second one, and here ester also does not give it. So acid chloride esters will not give this test, so it means the answer is option 2. Only propanone will give it. So now next up is question number 80. We can have a look at it. pH of the solution made by mixing 200 ml of 0.1 molar acetic acid plus 100 ml of 0.1 molar NaOH is. So we need to find the pH of the solution. So pH will be pKa plus log of salt upon acid, means how much salt is found, means product upon reactant. So this is the reaction that takes place. CH3COOH plus NaOH gives sodium acetate plus water. Now if we find the number of moles, because the molarity and the volume is given, so if we found the number of moles, it will be 2 by 100 for acetic acid. For NaOH, it's 1 upon 100. Now here 1 mole NaOH gives our 1 mole acetic acid. Here we will be getting 1 mole of sodium acetate. So number of moles of sodium acetate formed would be 1 upon 100, since here NaOH will be the limiting reagent. So now the number of moles of acetic acid left, because only one half will be utilized, 1 upon 100 will be utilized with 1 upon 100 mole of NaOH to form 1 upon 100 moles of sodium acetate. So how much acetic acid is left? 1 upon 100. So now we can put the values. pK value is given 4.7. Log of 1 upon 100 divided by 1 upon 100 means log 1, which is 0. So it will come out to be 4.7. Answer is option 3. Question number 81. Which of the following order of size is correct? Iron, cobalt and nickel. This one is correct. So they are having equal sizes. Okay. Now, because of the extra screening by 3D electrons, sulfur, chlorine and potassium. So that's also correct. Okay. Now if we look at option 3, this one is also correct, but option 4 may we know when we move down the group, the atomic size increases, but due to the filling of 3D orbitals, radius of gallium is lower than that of aluminium, so this one is not correct. So answer is option number 4. Among the following, which one is not formed in Hofmann degradation? Now we know that Hofmann degradation is used to convert the primary amides to primary amine. So here the amide is treated with a strong base like NaOH and halogenating reagents like we can have bromine or chlorine. So in this reaction we see that N-bromamide is formed, RCONHBr is formed. Apart from that, isocyanide gets formed in this case, okay, RnCO, and N-bromoamide A9 is also formed, Rn, and then we get this amine, RNH2. That is the end product. So we are not getting RNC. So the answer is option number 4. So this is not formed during Hofmann degradation reaction. So question number 83 says ionization enthalpy increases from second period as we move from lithium to fluorine. So we know when we move left to right in the periodic table, the atomic size decreases because electrons are added in the same shell and the nuclear charge increases. Okay, so increasing nuclear charge, it outweighs the shielding. What happens is the electrons will be tightly held by the nucleus, so that is why more energy would be required to remove the electrons. So that is why ionization enthalpy increase when we move from lithium to fluorine. So the answer is option number 2. Question number 84. For the reaction AB, following data was obtained. So concentration is given, rate is given. So we have to find the order of the reaction. So according to the rate law, the order of reaction would be determined like this. So we can write 3 equations for each of the given conditions, and from all the 3 equations, by solving them, we will find the value of x and y, which is 0 and y is equal to 2. So the overall order would be 0 plus 2, that is 2. Question number 85. Among the given pair which will not impart any color to the frame. So we have beryllium, magnesium, calcium, strontium, barium. These are all the members of second group of the periodic table. So we know that in comparison to other elements, beryllium and magnesium are smaller in size. They are small in size, so the electrons are tightly held. So electrons are tightly held to get excited by the flame. So they don't get excited by the flame, means the energy that is required to excite the electrons does not lie in the visible region. So they will not impart any color to the flame. So the answer is option 3. Let's go to the section B. Which of the following condition is not true for a neutral solution at room temperature? So at all temperatures. So we know that pH plus POH means for the hydrogen ions and for the hydroxide ions it's equal to 14, but it is only applicable at the standard temperature, means we can say at 25 degree Celsius. So it is not true at all temperatures. Answer is first and others are true. Which of the following is found only in RNA? So there are some bases given here. So this one is thymine, which can be found in DNA, and uracil is the base which is found only in RNA. So here the answer would be option number 4, because uracil is present in RNA. Oxidation state of phosphorus is minimum N. So we can find the oxidation state of phosphorus in all the compounds. In phosphine it's -3, because for hydrogen it's +1. Okay, and apart from that in P4O10. Okay, so it's P4O10. So whatever it is, we can find out the oxidation states. Like for NaH2P2 it will be +1, for Na3PO4 +5. So the lowest oxidation state would be in option number 3. Next is a structural isomer of compound with molecular formula C4H8 shows geometrical isomerism. Out of two isomers A and B, B has a higher boiling point as compared to A. So we know that geometrical isomerism is observed in but-2-ene, and cis isomer has more boiling point than trans isomer because of the symmetry. Okay, so because of the symmetry it will be having more boiling point, and moreover it has strong forces of attraction. So it means the answer would be option number 4. This is the cis isomer. Cis butene, this one is trans. So cis will be having more boiling point. So we have to find the structure of B. So that is cis. Now standard reduction potential for iron Fe2 plus to Fe and Sn2 plus to Sn are given. So the reaction is this: Fe2 plus will gain 2 electrons, it will convert to iron, and Sn10 will lose 2 electrons. So this reaction takes place at cathode, this one takes place at anode. So we know that E cell is E cathode minus E anode. So E cathode for iron it's given minus 0.44 minus 0.14. So we will be adding it plus 0.14. It will come out to be minus 0.30 volts. Because reduction takes place at cathode and oxidation takes place at anode. Now identify the incorrect statement for the series of reactions. So if we look at the given series of reaction, the reaction starts from benzamide. So it will be giving you aniline. So it's like the Hofmann degradation reaction. Then in the presence of NaNO2 and HCl, we get diazonium salt. In the presence of HCN and CuCN, we get C6H5CN. So steric ammonium nitrate test can be given by alcohols. So the incorrect statement is first one, because C, which is our diazonium salt, it will not give red color with steric ammonium nitrate. It will give red color with beta naphthol. This is true. And A on treatment with P4O10 gives acidity, this is also true, and other statements are true. P forms soluble sulfonamide with Hinsberg reagent, so aniline will give that sulfonamide with Hinsberg reagent. So incorrect statement is option A, so this is the right answer since it's an incorrect statement. Given below half cells reactions are given, then for 3Mn2 plus we need to find out. So now again in this question we cannot like multiply directly. What we have to do is we will reverse the second equation, so it will be Mn2 plus will give you Mn3 plus electron. Okay, so now we will be adding the equation. Okay, so 3Mn2 plus will give you Mn plus 2Mn plus. Now we will be like multiplying it with 2. So we will reverse the second equation and then add them. So the E naught will come out to be minus 2.69 volt. So the reaction is not possible because delta G value will be come out like because it is NFE naught cell, so it will be coming out to be positive and indicates that the reaction is non-spontaneous. Because the delta G value is coming out to be positive, so minus 2.69 volt, the reaction will not occur. Next question. Here we have to match the reactions. So benzene in presence of CO and HCl to form benzaldehyde, it's Gattermann-Koch reaction. Then RCOCH3 in the presence of NOx, it's a haloform reaction for ketones that is happening in this case. The third one is a reaction between alcohol and acid. It's esterification reaction. Ester would be formed. And in the last one, acid in the presence of red phosphorus and X. So it will be your Hell-Vollard-Zelinsky reaction. So the answer is option number 2. Next is which product is not expected. So here the reaction is given. So we can see the possible reaction takes place. First, in the presence of H plus, loss of water molecule will be happening. Carbocation will be there. Now, ring expansion would take place and we get a 6-membered ring. Okay, then the rearrangement would take place. So we get this product and H positive will be removed. Okay, so we have to tell which product is not expected. So now the next one is the carbocation. This OH is removed, so carbocation formed at this place. Okay, now the methyl shift will happen, and after methyl shift we get this product. So these two products can be there. Okay, so the second product is not formed in this case. So yes, the answer is option number 2. Next is question number 95. During estimation of nitrogen in an organic compound by Gelder's method, the ammonia evolved from 0.5 gram. We have 0.5 gram of the compound. It neutralized 10 ml of 1 molar sulfuric acid. What is the percentage of nitrogen? So we need to tell the percentage of nitrogen. Okay. So here we can say that if 1 ml of 10 milliliter of sulfuric acid, it is neutralized by 1 ml of 20 ml, 1 molar 20 ml ammonia. So 1000 ml of ammonia will have 14 grams of nitrogen in it. Okay, so 20 ml of ammonia will have 14 into 20 upon 1000 grams nitrogen. So the percentage of nitrogen we can find out, it's coming out to be 56%. So that's the answer. Next is 96. Which of the following orders of ionic radius is correctly represented? So we know that the radius of the cation is always smaller than the radius of the neutral atom because of increase in effective nuclear charge, and the radius of anion is greater than the neutral atom because decrease in effective nuclear charge. So the correct representation is the first one only. H minus is an anion, then H is a neutral atom, then H plus. This is correct. Second one is wrong. So here this one is also wrong because O2 minus has more negative charge than fluorine, so it will be having more radius. And similarly here N3 minus will be having the largest atomic ionic radius. So this is also wrong. So it's option 1. Next is in question number 97, we have to find out the product. So in this reaction, both phenoxide and ethoxide would be present. So both of them will be present, but ethoxide is a stronger nucleophile than phenoxide ion, so it will attack the benzyl chloride, this one, PHCH2Cl, benzyl chloride, to form PHCH2OCH2CH3. So answer is option 3. Which of the following elements cannot be detected by Lesane's extract or Lesane's test? So Lesane's test is used to detect sulfur, nitrogen and halogens, but it cannot detect fluorine because when we reacted with fluorine, silver fluoride that is formed, it is soluble in water, so there will be no PPT formed and we cannot detect it. Silver chloride, silver bromide will give PPT, but silver fluoride will not, so we cannot detect fluorine from it. In solid state, color of oxygen has been observed as pale blue. This pale color is because of, so in the case of the oxygen, the electronic transition state takes place from the triplet ground state to the excited singlet state. So the answer is option 1. 100th question, which of the following corresponds to sp2 hybridization? So we know that in sp2 hybridization, the bond angle is 120 degree because the geometry is trigonal planar. So trigonal planar geometry is there. So that is why the answer is option number 2. So that was the last question, students. Thank you so much.